we're going to take notes on relations and functions. A couple of terms that we need to recall before we move forward. Independent variable. The values of independent variable, we call them independent because we choose those values. Those values are chosen. And they don't depend upon the other variable. So we can always determine the independent variable when we're looking at it, looking at a problem, and say, can we choose this value, or does this value depend on what we have to choose? So the dependent variable, it depends on the independent variable, or it depends upon the input. All right, our input is our independent variable. It can't be determined unless we know something. So our domain are our x values, and our range, kind of writing it up here, are our y values. And a function. A function is a relation that each element of the domain, or our x values, are paired with exactly one value of the range. So we can see our example here. And here we have a function. Okay? Every x value is paired with exactly one y value. But the next one isn't, because 2 is paired up with both 1 and 3, so we would consider that not a function. So let's look at a couple more examples. I have 54. First thing I want to do is I look at all my x values. I see 54, 56, 55, 54, 56. When I see 54 and 56 repeating, my x values repeating, that's a good clue to say, okay, this might not be a function because 54 is matched with 112 and 54 is matched with 123. Therefore, it's not a function. Also, 56 is matched with 130 and 128. So this would not be a function. Okay. So here I have 5, 6, 7, 8. Obviously, that's going to be a function because they're not matched. I'm not going to worry if my y value repeats. That's not my concern. I'm concerned if my x value repeats. So taking a look at this table here, I have 1 and 1, and 1 is matched with 7 here, 1 is matched with 8 here. So this is not a function. And I should have said yes on this one, right? Okay, our functions can also be represented in graphs, and we can look at this graph. Okay, I'm looking at this x value. It only has 1 point above it. This x value happens to have 2 points above it. Because of that, I would say no, this is not a function. Here, all of my x values, okay, looking across, only have one y value to match it. So yes, that is a function. This circle, if you look, my x values have 2 values. my x values, excuse me, are matched with two y values. So no, that is not a function. Okay, there's another way that we can figure this out, and that's called the vertical line test. What we want to do is we want to take a vertical line. I'm just going to kind of draw one real quickly here. I'm going to take a vertical line, and I'm going to take it, and I'm going to move it across my graph. If it happens to cross 2 points at the same time, then it's not a function. Even though this isn't like a perfect line or anything, this is a function because this line does not cross 2 points at the same time. So I would say yes, this is a function. Let's take a look at this next one. This is a graph that maybe we're not familiar with, but if we look at it, this line doesn't repeat going through anything. So yes, that is a function. Finally, we have this z. Well, you can see this line is going through 3 separate points right here. So this is most certainly not a function. So we would say no. Obviously, you don't have a really cool line like me, so you could use your pencil, taking a look at something to determine whether or not it is a function or not. Now, we talked about domain and range at the beginning of our notes. What we want to be able to do is we want to determine the domain and range. And you've done this, but what you might not be familiar with is how we're going to notate it. Okay, it's going to be a little bit differently. So let's start with our domain. Remember, our domain are our x values. So to determine our domain, this is how we write it. This is how we notate it. I'm going to put a little brace here, and I'm going to say y. And I put dot dot. And when I say dot, when I put dot dot there, I say in my mind, such that. Y, such that. Okay, does that make sense? This is what the dot dot actually means. Y such that. And I'm looking at my y values for this line. I'm looking at from where it is. Because I'm going with continuous lines here, I'm looking from here all the way up to here, which is where my line ends. And it doesn't matter that it's not a function or anything. We can still determine whether it's a domain and range. We're stepping away from functions, determining whether or not they're functions, and we're talking about how to notate domain and range. So my domain, excuse me, my domain is not y. Let me get myself straight here. I apologize for that confusion. My domain are my x values. So my domain is braces x such that. All right, now that I'm straight here. It's a Monday morning. -4 all the way up to +5. So I'm going to write -4 less than or equal to x, which is less than or equal to 5. Write my braces. Because x is anywhere between that -4 and that +5, and this is how we notate it. My range. Now I'm on to range. Okay, these are my y values. Again, my y values are running from -2 all the way up to +4. So that's going to be y such that -2 less than or equal to y, which is less than or equal to 4. End my set notation. Okay, so that's how we need to be able to notate domain and range. This is something that you will be responsible for. Okay, now we're going back to functions, and we want to go ahead and talk about how to apply it. Okay, this is an application problem. I'll let you read the problem. Okay, if you need to pause, please pause. Identify the independent and dependent variables, then write a function to represent the total cost of any number of people in the portrait. Okay, we're going to get more into function notation, but we can most certainly talk about how to set this up in an equation. So since the cost depends, again, it's a Monday morning. Oh, I was right, depends on the people, okay? It's the number of people that really drives the cost. So my independent variable is going to be people. My dependent variable is going to be the cost. And I'm going to go ahead and set up an equation that cost equals 125 plus 15p. Okay, it's $15 sitting fee per person. That's why I'm putting 15 and p right next to each other. And then I have the upfront cost of 125. So all I need to really do is I need to substitute in how much they spent, which is $215. Subtract 125 from both sides. I have 90 equaling 15p. Divide by 15. And p equals 6. That's how many people there were. Thank you.